Hey everyone, it looks like we're live. I'm in the chat right now. So hopefully the stream quality is working pretty well. It said it was bad to start, but if you are in the chat, go ahead and say hi. And let's hope the stream is working well. Let's see. I'm getting buffering issues. Who is in the chat? Hopefully. Is anyone else having buffering issues right now? Anyone else having buffering issues? Hey everyone. So it's interesting. Let's make sure it's going all right. I'm just reloading my stream. I've got my stream up here, and so usually it flows and it works and I can see what you guys are seeing. So I hope we're not experiencing buffering issues. How is the buffering? Let's see. I'm seeing really bad image quality. Okay, good. Well, is everyone streaming it straight? Well, I wonder why it's acting so weird on mine. Well, it might just be my laptop or something. I know the image, we don't want the image to be kind of blurry. So hopefully everything's going to work all right. Everything is good. I'm seeing very blurry image where I can't even read your guys' names. How's it? Can you guys read the names on the screen? This is my heart starts beating a little bit quickly. Good. You definitely say hey in the chat. Okay, maybe it's going to start catching up and start buffering properly here. So, what would you rate the image quality and video quality? Because I am just seeing tons of buffering right now, and I wonder why that is. I have no clue. Might even reset my main PC. That might be the issue. Well, as long as it's readable, that's good. I wish it was top tier quality, so we'll keep our fingers crossed. Maybe, maybe my video is not working so well because I'm also streaming, and that might be taking the bandwidth. Oh no. Or let me do this. Let me take and drop. So it says my stream quality is okay, which is not. Please check your video resolution. It says my stream quality is okay. And I'm just closing out some windows right here. I don't think those would impact it in any way. And I'll hop back into the chat. How's everyone doing? How's the weekend been for you guys and gals? Wait, it's 9 out of 10 now. I like that. I want it to keep good. Oh no, Elizabeth. Well, hopefully everything stays strong. It takes a lot of bandwidth on my main computer right here. And let's hope it keeps going strong. I'm going to try reloading this page for myself too. So let's hope it works. Fingers crossed. We're going to start here in about 5 or 6 minutes. And let's hope the bandwidth is working because I've never... Oh, seems to be working-ish right now. I don't know why. It did well before. So we've had no issues, and now I feel like there's slight bandwidth issues. Okay, I need someone to tell me what the delay is because I also want to make sure the delay is not too bad. I just keep seeing buffering stuff. Who wants to be my delay person? Who wants to be my delay person? You're going to help me to see how long the delay is because that's my only worry right now. Sweet. Okay, Jack, here's what we're going to do. I'm going to snack Jack, and when I snap, I want you to have written snap. So have written snap, and when you hear me snap, you hit enter on it. So that's where we're going to see what the delay is. And so I'm going to count out the delay. I just want to see what it's working at right now. So have snap written, and then when I snap, you hit enter. So you'll hear me snap later because there's a little bit of delay. So here we go. 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5. Okay, we got about a 4 or 5 second delay, which is all right. That's, I think, what we're usually at. Thank you guys both for doing that. I really appreciate it. And I guess we'll get started in about 3 minutes. Any questions about the test? Because that's what we're all here for tonight. I guess it's just going to buffer for me, but no one else is complaining. So I guess it's working well. I might not. Let me take down... I think I can pause my stream and not worry about. So, crackle, I like it. I like the crackle right there. Is it easier or harder than exam one? Here's the good news about the second exam. There's less material on it. There's less material on this exam, which is, the good thing. So let's think about what's all on there. Starting all the way back with decision trees, and the code is available on our site, so make sure to go to the course page for it. Make sure don't give the code out in the chat. Make sure to put it, go to our site. The practice test is very similar, I would say. And thank you those who are removing, what's the course code, or what's the code for this, because remember, if people get in here, they will crash it, and they've done that to us before, so we won't let them do it. But the exam starts with decision trees, which we're not covering tonight, unfortunately. It's hard to get those questions in here. I'll answer some questions at the end related to decision trees if you want. We also have randomness. We have sample surveys. We have sampling distributions, probability, and confidence intervals. So that is all the material for exam 2 right there. Let's see if we can break 100 people in the Kahoot. And I will have in my office another $5 Starbucks gift card. I owe Mitchell, and I believe it's Madison. Both are winners so far. And remember, keep the chat going. That's kind of what keeps me talking to you guys. Ask those questions in the chat. Let's start at 8:10. We'll start at 8:10, and I hope everything's working right. There is study material on the stats page. Videos included. Helps a lot. Awesome, Mario. And glad you found it, Mario. Remember, if people come in and ask for the code, don't give it to them. How long will it take to take the exam? Great question. Oh, the review. Probably 60, 70 minutes. We'll go till about 9:30 at the latest. But also, listen up. As I give the questions, I give more info. You can only type so many characters into these Kahoot questions, so I'll give more info to them. So I'll give as much information. I'll also drop hints. Have a sheet of paper out with you right now. So have a sheet of paper out. Have something to work with. You want to make sure that you have paper, pen, and all that good stuff. So make sure you have that. So we'll do that. And let's see. How do you study the true-false questions? Trying to think if there's a good way to do it. Studying the true-false, I would say just review the concepts, review the slides, review also the material with... I have videos up to help out with it. I have study review videos, and those are the ones you want to work with. You want to go to the chapter review videos and use those right there. Next time we do this, I think we might have to make this an unlisted video. We'll see what happens. So we'll wait just 1 second here and let the names kind of get moved out of the way. So we will see right here. That's interesting. Yeah, it's interesting. We're going to see what's going to happen here. And we might have to play the home version of it. We will see what happens. We can always make it work. The normal curve questions are for Chapter 15. We'll get started in just a moment. So we'll see what happens here with the Kahoot. The normal curve questions are Chapter 15. Or 13, excuse me. The chapters literally just changed over the summer. So chapter 13 is the normal curve questions, where at least where we use the normal curve, we will give you the z-scores, and that's the way we'll help you out with those. We've got some good ones on here. And let's see, is the final cumulative? We do have review questions on the final that are the tools and technique review questions. So we have those in there to help you out, to kind of go through questions like, when would you use a scatter plot? Like if we were measuring height and weight, we'd use a scatter plot for that, and would use tools like regression. So that's what we have right there. Decision trees, definitely do the output, look over your project, and feel free to email me any questions you have on decision trees. The one on the practice test I think is great. There's only so many questions we can ask. It's not that in-depth of a chapter. So basically know how to read the output for decision trees and be able to kind of interpret it. So you've got, let's just review that real quickly here and we'll do it again at the end. Decision trees, you need to know what the split history is. You need to know what the leaf report is. And you need to know how to read the tree and know what the numbers are in the tree. There's things like Gini and log worth in the tree that we don't talk about. So if it's not in the notes, don't worry about it. Things like count, mean, or the percentages, those will be very important. And with that, no further ado, do we need to know jump, normal curve, side up? Just how to read the normal curve, how to do certain numbers on it, and we will give you the z-scores on this test if you're making confidence intervals. So confidence intervals, definitely. Confidence intervals are on this test. Is everyone ready to get started? Let's see some people in the chat saying they're ready to get started here. So, how's everyone doing? Let's get started. We got the 5-second delay here. And then remember, answer the questions in the chat, and we'll go ahead and get started. I will also read off the questions as we start this up here. Hopefully we're still in the 5-second delay. Thank you everyone in the chat. A researcher selects the first 20 roads next to their house. So think about this. They take the first 20 roads next to their house. What kind of sampling method would this be? Now, there's trick ways to do this. This one's not meant to be a trick. This one is meant to be straightforward, and they're all randomized, so we're going to see different questions throughout the night in different orders. But if they select the first 20, now these are not a random first 20. These are the easiest things for them to get to. And thus, with it being the easiest things for them to get to, this is definitely a convenience sample. So nice job, everyone right there. Can they see the question? Oh, no. Okay, let me do this real quick. Let me hop over to this. I am very sorry. Sorry with all the craziness. Okay, can everyone, we can see the question now. Sorry, I can't repull the question. Basically, I read it off though too. Sorry about that. Yes, you should be able to see the question. I'm very sorry about that, everyone. With all the craziness, I forgot to remove the sign. Okay, so that one's a nice and easy one to start, and I think most people got it. I did read the question too, so we got that. Thank you for everyone saying we can't see the question, and now we can. Let's go to question number 2. Remember, ask questions you have between the questions, like what is convenience sampling? Convenience sampling, which also is convenience bias, is when we take the things that are easiest to get to. It kind of goes with voluntary bias, where things might volunteer, like people volunteer. I also think that that's kind of convenience bias. It's convenient to have volunteers. Of course, voluntary bias is when people volunteer, and a convenience sample leads to convenience bias. You wouldn't speak to the first 20 people you see. You want to speak to 20 random people. I'm sorry. Maybe next time we'll reserve a classroom. That might be a good idea, Mario. That way, that's a good consideration. Maybe for the final we'll do that, and UT Wi-Fi is even better, so then I can make sure everything streams even better. I like that idea, Mario. Let's continue on to question number 2. Oh, we'll get to that, Alan. We will get to that. I promise there'll be clustering and stratified, and you'll hear all about that. We got Clever Macaw in the lead. See, everyone just wanted to win that Starbucks gift card. A researcher lists all road and randomizes the order and then selects the first 50. Okay, now be careful with this. They randomize the order and then they select the first 50. So they've made it completely random and then they select the first 50. So what kind of sample would this be right here? When they randomize the order and then they select the first 50. What would that be? And you'll notice, we don't say that they just select the first 50. They take it randomly. And this is a bit of a trick question right here. Looks like a lot of you got it correct. Don't worry, we just get a bunch wrong sometimes, and that's all good. What is circle? Mine is so blurry, can't read. No! Maybe I'll read it off next time. I'm sorry. I think we might have some streaming up bandwidth issues. So what we have right here is they randomized it, and that's the key. When we take a simple random sample, it's because we've actually done it randomly. And I know it sounds crazy that this is a simple random sample and not convenience, and not many people said convenience, I think because we already did that one. But if we randomize everything and then select the first 50, it is completely random. So it's completely random when we randomize it and then select the first 50. If you're taking notes at home, make sure to be taking those notes. Have a sheet of paper out right now. Write down convenience right now. And convenience sample, that's when you take the first few things you have access to. It's the easiest thing to do. Then next, write down simple random. That is when you give everything a random number. Everything in the population has been enumerated, and it's given a random number, and then you pick those randomly. So you should be able to identify what is simple random and what is convenience. This is just a definition review right here. You got it. Make sure to ask those questions in between each one, and we'll continue on right here. Okay, we got Sturdy Dolphin in the lead. Got a lot of people leading the way here. I'll also read off the answers for Mario. So sorry about your internet there. Okay, this is a randomness question. So what you see up here is the random trials, and heads is 0 through 4, and tails is 5 through 9. So I want to know what percent of the time did you get 2 tails? So what percentage of the time did you get 2 tails? So be writing this down right now. Let's try the first one right here. 0, so that's the first thing, is heads. 2 is heads. 3 is heads. And then we have 8 and then 2. So 8 would be tails. In the first series, we got 1 tails. So if you look at what's going on right here, this is what percent of the time did you get 2 tails? Exactly 2 tails, Abby. Exactly 2 tails. If you notice right here in the first trial, we got 1 tails. And then in the second trial, let's see right here, we got 2 tails in this one. So we got 2 tails with this 2 and with this 4. How about this one right here? We got 3 tails, 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 and tails. And then right here we didn't get any, or 3, and then 5. So it looks like 1 time, which is, or did I make a mistake? Let me see here. How many times did we get 2 tails? Oh no, sorry, with all the craziness, I was thinking heads were tails and tails were heads. Oh no, this is, I know, Tropical John. Oh, nice job, Tropical John. I was reversing it and I wrote the question. No, I am very sorry. So that was me trying to trick you, not on purpose. And I want to pause with this, because simulations are easy to make mistakes on. When we give you a simulation question on the test, remember, this is all just for fun, and obviously I make mistakes too. But when we do a simulation question, it's easy to forget the rules behind it. As you see here, it says tails is 5 through 9. So that is 1 tails right here. As you look at what I'm showing you, that 8 is a tails. I got 1 tails here, and then I got tails, tails, heads, tails, heads, and then I got 2 tails here. So that's one of the occurrences of 2 tails. And then here I also got 2 tails. So I got an 8 here and a 9 here. No, Mark, I'm sorry. How bad is the lag, guys? So we can do a snap check right here. Go ahead and just type S for snap when you hear the snap. Let's just see 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5. Okay, we're still about a 5-second lag. So it's a 5-second delay about. Oh man, if you guys are hearing, hopefully everyone's about at a 5-second delay. I should really put every question at 60 seconds, and hopefully, but this is the quickest YouTube can do it. Or maybe I'll put them all at 120 seconds. I'll talk more. But give these suggestions for exam 3, and we will do that. So once again, let's review what we should do on simulation when we get to the test. Be very careful, and I didn't do that mistake on purpose. Be very careful and check all of your answers. Be very, very careful and do each simulation the way the rules say, and then check your work. And it never hurts to ask us a question. We're not going to give you additional unfair information that other students wouldn't get, but we will explain, wait, is this 2 heads or 2 or more heads? And it never hurts to ask. Just ask us and we'll explain in better detail if you don't quite get it. We can't give you additional information like I said before, but we will try to help you understand what the question is going towards and help you figure out how to do it. It never hurts to raise your hand, so feel free to do that. And remember, how did you get the number? We got 40% because in this trial right here, does everyone see this 9 and this 7? We have, that is 2 heads because this is heads and this is heads. And oh my gosh, this is tails and this is tails and this is heads, heads, and heads. Tails is 5 through 9. 9 and 7 are tails. And in this simulation right here, this one trial, we got 2 heads. And then in this one, we got 2 heads right here, this 8 and the 9. And these are the only 2 occurrences. Thank you very much, Ruth. Ruth says 2 out of 5 in the chat, and that is 0.4. And so you would say in this trial and this trial. If I was doing this on the test, I'd put a check mark underneath those. I'd maybe underline each time that I got tails, like I would underline this here, and underline this here. And then I could visually see for myself where I got the tails. And make sure it's really easy to make a mistake with heads and tails or rolling dice or anything like that. We can make a mistake. So good job, Renee. Always glad. Keep asking those questions. I'll answer everything you guys have in the chat. So we have Clever Macaw. I think they were in the lead last time. Let's see who's got it next. Ooh, I like this one. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P? And P stands for the population proportion. P stands for the population proportion. So we need to figure out what is the population proportion. What is the population proportion? And this is a chapter 13 question for the sampling distribution of the sample proportion. N is 30, which is the sample size. Oh gosh, 200 is 30, 200 is N, which is the sample size. 30 is X, and the population proportion is 20%. And let's just think about this right here, because in the question it says, we know UT is 20% freshman. Now, if you answered 15, this is a great time to pause and see where you have a knowledge gap. So what is 15 here? I want to see it in the chat. What is 0.15? What is 0.15 in terms of this problem? And it's probably going to help us out for later in the Kahoot. What is 0.15? Yes, definitely get a calculator out and definitely write these down, like P is the population proportion. And Abby, you are right. 0.15 is P hat. So P hat is X over N, and that is P hat. You'll notice in this problem we have X, which is 30, which is how many successes there were, and 200 is N, which is the sample size. So P hat is 30 over 200, and P is just the truth for the population. And so there's lots of great things we'll use this for. We have the formula mu P hat equals P, because we estimate the mean for the sampling distribution of the sample proportion to be P. So let me ask you this question. If UT is 20% freshmen, and we go out and sample freshmen, or we go out and sample people at UT, what percent would we expect to be freshmen? If UT is 20% freshmen, and we go out and sample, what percent of people would we expect to be freshmen? So just think about how that works. UT is 20% and there we go. Ben, nice job, and Ahmed, great job. If UT is 20% freshman and I go out and sample, I'd expect to see 20% freshmen. And that's why mu P hat is equal to P. That's the mean for the sampling distribution of the sample proportion. And just think of mean means what we expect when we go out and sample. If I go out and sample, I expect to see the true proportion. That is what mu P hat equals. I'm going to write that in the chat right here so everyone can see it. I'm going to use a U for mu. I'm going to write mu P hat equals P. So that's in the chat right now. Ignore that slash next to it. Mu P hat equals P. That stands for the mean for the sampling distribution of the sample proportion equals P. And theoretically what it means is if I know 20% of UT is freshmen and I go out and sample, I'd expect to see 20% freshmen. And that's what you'd put at the center of your curve. At the center of your curve, you would put 20%. Does that make a little more sense to everybody, especially when we put into words there? If I go out and sample, I expect to see the truth, which is the population proportion. That's the way it makes sense to me, because it's like, why is mu P hat P? It's just saying what you expect to see when you sample is the truth. It's the most likely thing at the center of the distribution. So ask those questions if you got them in the chat. This is the sampling distribution of the sample proportion, and how it's how we figure out what mu P hat is. And we'll continue on to the next question. You want to Kahoot yourself? Let's continue on to the next question. Joyful Goose. Oh no, did we lose? Clever Macaw fell behind a little bit. Oh no. Yes, be careful. Let's continue on. A researcher selects every fifth road on the listing of roads. So a researcher selects the fifth road on the listing of roads. What is this? Every fifth road. And now, truthfully, they would need to start at a random starting point. And we'll review these definitions. Make sure to ask your questions in the chat. But if you pick a random starting point and then you sample every kth observation, a random starting point and you sample every kth observation, what is that? A random starting point and every kth observation. Nice job. You guys got this down, because that is systematic. I got to make sure, walking and talking here, saying everything, I'm about to read the wrong one. But systematic is the right answer. And the two rules for systematic are: one, select a random starting point. And you can kind of assume that someone selects a random starting point. It really, in true systematic, they really need to select a random starting point. That helps with removing some order variation that we might get if we don't take a random starting point. After taking a random starting point, you select every kth observation. Basically the blank number, eighth number, it's systematic. That is correct. That's kind of the key characteristic of it. That's the main part of it, is taking every kth observation. It could be every 10th, 20th, 50th, 100th. Usually we space it out along the interval. Like if you were checking, if you worked at a pizza factory and you're making pizzas, good factory to work at, you might take every 50th pizza and do a quality check on it. So, that right there would just be your 50th quality check to make sure the machines are working properly. I don't know, maybe this is like the DiGiorno pizza factory. You're like, hey, we need someone to sample this pizza. It's a good place to work. But with that in mind, systematic is really every kth, and then it does have the aspect, take a random starting point. So make sure to have these notes down. First thing, take a random starting point. Second thing, sample every kth observation. That is how we do systematic sampling. So a random starting point and every kth observation from then on. Let's continue on. Keep asking those questions in the chat. And let's see, we still have Clever Macaulay. I don't know, I'm rooting for Clever Macaulay. They were in first to start. I don't know who you are, but you're the person I'm rooting for. I want to see you make the comeback now. Read the following as a sentence. This is one of my favorite ones. We do this in class a lot. So we have, and I have to try to not read it, probability of A plus probability of B times probability of C. And you kind of have to know the way the words go with this. You have to know what plus means as a word. Now, plus has the disjoint rule, which means it's the addition. Well, it is addition, it's plus. Star has multiplication, and it has the independence rule. So we have probability of A or B and C. Nice job. And these are the key words we use right here, so take a moment and pause on this. When you see plus, think of or. And just let's try a little of the math right here. Try it in the chat with me. So what if I told you the probability of making, let's say, an A in a class is 40%, I like it, and the probability of making a B is 30%. What is the probability of making an A or B? What is the probability of making an A or B if the probability of A is 40% and the probability of B is 30%? Nice job, Allie. Allie says 70%. You are correct. And why can you add those together? Why can you add up the probability of A or B? Why can you do that? I said it earlier, like, why can we add up 40% and 30%? Why does that work when we say, what's the probability of making an A or a B? And I can just straight add those together. And the key here, I see a few people saying things that are different. It is that they are, I want to see a few more people say it in the chat. We've got two answers. They are disjoint. They are disjoint. Yes, I like that. Alan's seen my thumbs up, thumbs down. Alan, did you, or I think it was Alan who said that. I think Alan watched the video. I do the thumbs up, thumbs down. I watch it in the class. And it's tricky. This is why I ask, because a lot of people say independent to it. What disjoint means is if one happens, the other can't. That's how you ask yourself disjoint. I wish I could see it. Hopefully you guys can see my thumbs up, thumbs down right here. As soon as one happens, the other can't happen. So with this right here, if you make an A, you can't make a B. Thus, the events are disjoint. If you make an A, you can't make a B. Disjoint means one happens, the other can't happen. That's the way it goes with disjoint events. And Abby, you are correct. That is the same thing as mutually exclusive. So they're exclusive of each other. They can't both happen at the same time. They are mutually exclusive events. And let's see what else. On the exams, will you take percentage or decimals? We should be good either way. Usually says to 2 decimal places. So if you do a decimal, probably do 4 because that can be kind of close. So usually we say 2 decimals unless otherwise told to you. And percentage or decimals, if you see something weird with your grading, immediately talk to your teacher and be like, this is not graded right. And we'll look at it. We'll tell you what we think. So this is a good review right here of how we add things together. And remember, they need to be disjoint. Now, what is the rule for the multiplication? To multiply 2 events easily, there's more rules that we don't get to in our class, but to easily multiply 2 independent, I just said it. To easily multiply 2 independent events, we just multiply them together and they need to be independent. And that's the multiply probability of B times probability of C. That assumes independence and we just multiply. So we will continue on to the next question and keep asking those questions in the chat. To multiply the probability of A and B, the 2 events must be, this is quick review right here. These are all randomized, so we don't know which one we're going to get, but you guys should get this right away. Remember, we're talking multiply right here. Take these notes. These are quick things you should know instantaneously. It's kind of the way I run the Kahoots, is that you should be able to just tell me, to multiply the probability of 2 events, the 2 events should be independent. I know I'm giving that away a little bit early. People should have just a few seconds to ring in on it, but they should be independent. Let's see, we just gave that one away. Hopefully we're good. Nice job. We have a lot of people saying independent right now, and that's what we have. It's just the way it works. When you do multiplication, you'd say the probability of A and B, and you would multiply. That is correct. Raven, you are correct. It's literally like, what's the probability it snows tomorrow and we get school off? Now, can we multiply those 2 events together? Can we multiply those 2 events together? If I say, because it would snow and we get school off. And so when I say and, they're happening together. Can we multiply those 2 events together with our usual rules that we have in this class? Can we multiply the probability of it snowing times the probability of us having school off? Should we? Well, think about it. You have to ask yourself, here's how you do the independence. You ready? You say, yes, Alex gets it right there. Nice job, Alex. You say to yourself, it snowed. Does that tell me anything about school being off? And you can ask, school's off. Does that tell me anything about snow? And if for either one you think it gives you some information, then they are dependent, i.e. not independent. And you would say it snowed, it's more likely we will have school off. That's the big thing. If it snows, it is more likely we have school off, so you cannot multiply those events. Does everyone understand how that example works? Since knowing that it snowed gives you information about school being off. Yes, good job, Tropical John. I like that name there. So I wish it snowed tomorrow too. That'd be great. You guys want snow on Wednesday, right? Wednesday's the day for snow. That'd be crazy. We've never had to reschedule a 2-1 exam. They're usually far enough away from snow dates, but that'd be fun. Because we have to do a lot to reserve all the rooms, and that'd be interesting. I hope we never run into that scenario. We would not have fun with that. But once again, when two events are independent, write this down as a definition. Knowing one event happened tells you nothing about the other event happening. So let's see. Are disjoint events independent? Are disjoint events independent? I like it. Ren asks a great question right there. Are disjoint events independent? And correct. Disjoint events are very dependent. So when we have a disjoint event, if one happens, you know the other doesn't happen. Does that make sense? When you have a disjoint event, means one happens, the other cannot happen. Think about, once again, the probability of making an A in a class and the probability of making a B. If you make a A, you cannot also make a B. So if you say to your parents, I made an A, would they ask, did you make a B? You'd say, I already answered that question. I told you I made an A. And they say, well, no, you didn't tell us if you made a B. Because knowing you made an A tells them if you made a B. Hence, they are disjoint events. Now answer this. Is making an A in a class independent or dependent of making a B? Is making an A in a class independent or dependent of making a B? We've already said that A and B are disjoint events, and exactly, you'd say very dependent. Nice job, everyone saying dependent in the chat. Don't worry if you make a mistake. This is our review. Because they are dependent because making an A depends on if you made a B. Because if you see you made an A, you know you didn't make a B. It gave you the information. You see A, you know you didn't make a B. So remember what disjoint means, and remember what dependent means, and independent. Disjoint means if one event happens, the other event cannot. That's the same as mutually exclusive. Independent means knowing one event happened tells you nothing about another event. Dependent means knowing one event tells you information about the other event. It doesn't mean you know the other event, but it means it tells you information. Like, it snowed. That doesn't mean I know we'll have school off. It just means it's more likely. It has increased the probability of school being off by it snowing. Great review right here, and that's what we're here for, and to have someone win. And then email me if you win to get that Starbucks gift card. Take a screenshot of your screen too with you as the winner if you can, and that's the best proof I can have, unless 10 people email me and say, I won. I'd be like, who won? I like it. I like that, Cameron. We'll continue on right here. Let's see here. No, we lost our macaw. Two events that have no influence on the probability of each other are... we just did this. So two events that have no influence on the probability of each other. I swear these are randomized. Two events that have no influence on the probability of each other. It's kind of a really good review. I think it's listening to us. I'm pretty sure they're randomized. Yeah, I made them in order of the chapters, so I don't think we'll pause after this one too long because we just went over this a lot. If two events do not influence the probability of each other, they are very, very independent. Let's see here. So yes, better job on that one. I think we're getting it down. Two events that have no influence of the probability on each other are independent. If they influence each other, they are dependent, and that is the literal definition. So we will continue on right here and go on to the next one. UT is 20% junior. From an 80 students, 30 are juniors. Find the standard deviation. Okay, we got to get your calculator out, pull up your calculator on your computer, because we need to find the standard deviation of the sampling distribution. And let's go ahead and write that formula in the chat. It's good practice. I'm going to write it in here. It is square root of p hat times q hat over n, and this is all quantity right here. It is p hat times q hat over n square root. So you need to find p hat here. P hat is 30 over 80. So I'm working this problem with you as you're working it, hopefully. So P hat is 30 over 80, which I believe, oh my brain's breaking down tonight. P hat being 30 over 80 is 37.5%. And then Q hat is 62.5. So 32.5 times 62.5, 0.325, 0.375 times 0.625 over 80 square root. And we should see what the answer is. Anyway, you can display the question so we don't have to memorize the numbers. Oh, do you not see it at the top there? Let's see here. Do you not see it at the top right there? So make sure to have your calculator out. Sam, were you able to see the question at the top? Should be. So are you just doing it on your phone, Sam, or listening to me? Other people can see the. Oh no. Can everyone see the questions as I'm doing them right here? The questions should be displayed. How do we find Q hat? Let's see this right here. P hat equals, and if we can confirm people can see the questions because they should be available. P hat is this right here, which should be that. And then Q hat, good, I'm glad you guys can see the questions. Thank you very much. I think everyone should be able to see the questions. I am putting the answers for P hat and Q hat in the chat right now. Okay, good, Sam. I'm glad you can see them there. Have a calculator out. There's only going to be a few more that require calculators, but does everyone see this right here? Join by going to our page and getting the code. What's the difference between P hat and P? Great questions. So let's see here. What's the difference between P hat and P's first question right here? P hat is the sample proportion. Now let's look at this right here. What is the sample proportion for this question? It is 30 out of 80 because in our sample, we saw 30 out of 80 juniors. Does that make sense right there? 30 out of 80s is the sample proportion. So wait, let's see out here. So, and then 20% is the juniors. 20% is the amount we actually have in the population. Make sure don't put the stuff in the chat because you never know, we might get spammed again. So does everyone see here? P is 20% right here. Yep. So let's see right here. We should get 0.045, and I hope. Has anyone confirmed? We played this earlier a few days ago, and I think I know why you're getting 0.055. Tropical John, can you write your equation in the chat? I'm gonna write mine right here. I'm writing my equation as we speak right now. Good. And I think 0.055 is the trick, and people can confirm my equation right here. Yes, that's the trick. I'm sorry, everyone. I threw that trick right in there. So thank you very much, Tropical John. And make sure it is square root P hat times Q hat over N. And yeah, that was definitely a trick I put in there. I'm sorry. I know that was mean because a lot of people, yes, you can see why that was the second most used answer. And I really want to point out, why do you use P hat instead of, or why do you, so great question, Raven. Raven says, why is it P hat times Q hat over N square root instead of P times Q over N square root? And, oh my gosh, is this the wrong answer? Ay. Can we confirm? Let me see here. I think there's a wrong answer on the Kahoot. Oh my. See, don't worry. We all make mistakes. I'm working the problem right here because I think, sorry, with all the craziness tonight. So the correct, oh good, no, the correct answer, I am sorry, everyone. The correct answer is, I have been doing it wrong in the chat. I am sorry, everyone. Sorry, working a problem while doing it. And sorry, this will be the last wrong answer tonight. We got them all out of our system. This is the answer right here, and let's review. Tropical John, you got it right, Tropical John. I'm sorry, this is probably the biggest error I've made. No more errors, right? We get it out of the way. Because why? Let's talk about why right here. Raven, thank you so much for your answer. No cringe, Mark. So here's what happened right here. You ready, everyone? For the sampling distribution of the sample proportion, it is P times Q over N square root. And we have to make sure we remember the differences between our formulas. Because when we do the confidence interval, we use the difference between P hat, Q hat over N. And why with a confidence interval do we do P hat times Q hat over N square root? Why do we do that for a confidence interval? And I know a few people in my class know why we use p hat times q hat over n square root for a confidence interval. So why do we use p hat times q hat over n square root for a confidence interval? And why in this one did we do p times q over n square root? Why in this one did we do p times q over n square root? And why for a confidence? Exactly, Raven. You are correct. Nice job, Raven. In a confidence interval, we don't know p. In a confidence interval, we have a sampling. We just have our sample. So when we know the truth, we will use the truth. In this problem, we know the truth, and we're building what we might expect to see if we sample. Hence, we will use p times q over n square root. And when we make a confidence interval, we don't know the truth, so we use p hat times q hat over n square root. And that, so basically, Alex right there, we use p hat if we do not know p. And when we don't know p, we'd make a confidence interval to estimate the truth. Does that make a little more sense to everybody right there? I'm just resetting my mind after all the craziness and randomness and making sure every question is correct. I thought for a moment I had the wrong answers on here, but I don't. I tricked myself. Never any good. What is p? P is the true proportion for the population. In this problem, p is 0.2. So thank you, Raven, for asking. I really appreciate it. I love when you guys ask the questions. So p is the true proportion for the population. We know UT is 20% juniors. So we will do p times q over n square root. 0.2 times 0.8 over 80 square root. So keep going right here. Okay, we'll go to the next question. So this is a pretty tricky one right here. We've got gross jelly beans is 25%, and you eat 3 jelly beans. What's the probability that they're all good? Actually, this one's not that bad. First thing we need to do is figure out the probability of a good jelly bean. And you will get formulas on the test, Kara. You will definitely get formulas. So what is the probability of a good jelly bean here? First thing we need to figure out, probability of a good jelly bean. And think about this. You eat the first jelly bean, and it's good. And then you eat the second jelly bean, and it's good. And the third jelly bean, and it's also good. So if the question didn't give you 20%, would you subtract 30 and 80? 30 divided by, well, that's p hat right there, Carly. So that would be p hat is 30 over 80 is p hat. And the question, if it's the sampling distribution of the sample proportion, would need to give you p, if it is related to that. Good question. I like that. So right here with this gross jelly bean, we have so much time on this one. I feel like it should have been a 60-second one, but it's a math one. So I give you guys a little more time. We know the probability of a good jelly bean is 0.75. So listen to the words and just think it out. Imagine it. You eat one jelly bean and it's good, 0.75. And you eat another jelly bean and it's good, 0.75. And you eat another one and it's good, 0.75. So with that in mind right here, we have the first is good, and the second is good, and the third is good. And they are independent, Tropical John. They are going to be independent for this right here. We are going to do independence because let's say it just comes from a big vat of jelly beans and we say, okay, 75% of them are good. And it's not really going to change because it's just, infinite jelly beans. So assuming that they are independent, which we can do for this problem, this is a trick problem. We cannot answer this. But we would multiply. And let's get the equation in the chat because people can see the chat afterwards. So feel free to put those equations in the chat. And let's see you guys write the equation on how you got the number you got, especially for the people watching. Definitely helps them out because the test is on Wednesday. Tropical John, nice job, 0.75 to the third power. And when you solve that right here, you will get 0.422. The first was good, and the second was good, and the third was good. Now let's pause here and actually do a more difficult one that will come in a moment, because I believe we should always review what we're doing. A later question is going to ask you something like, what is the probability at least one is bad? So what is the probability at least one is bad? How would we do that? Because they'll either be all good or, I know, Tropical John, you are leading the way. Because they'll either be all good or at least one is bad. And you guys see it right there. Now keep this in mind for a later question. I think it's that question. We'll see. It might be that there's at least one good. We'll find out the hard way when we get to the question. But just think about what you've written. You've written everything but they're all good. One is everything, minus is but. Everything but they're all good is at least one is bad. Let's try another problem right here, right now. Write it down. Let's say you flip a coin 5 times. What is the probability there's at least one tails? You flip a coin 5 times. What is the probability there's at least one tails? A coin is 50-50. It's also independent. So what is the probability there's at least one tails when you flip a coin 5 times? Write it out in words or write it out mathematically in the chat right now to do the probability of at least one tails. Flip a coin 5 times and there's at least one tails. These are some of the tricky ones that really are tough for people to do. And when we think about it, they'll either be all heads or at least one will be tails. And Tropical John is on fire, and nice job right there, because it can be 1 minus all heads. So if you look at it that way with 1 minus all heads is 0.5 to the 5th power. That's the probability of all heads, because the first was heads, and the second was heads, and the third was heads, and the fourth, and the fifth. So 1 minus all heads. And that's a good question, Elizabeth. Just think about this right here. When you flip a coin 5 times, one of the outcomes is heads, 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 5 heads right there. So that is one of the outcomes. And would you agree with me? You will either get all heads or there will be at least one tails. So let's say this right here. All heads. And then we have right here plus at least one tails. So if you're looking in the chat right now, does everyone agree that when you flip a coin, you will either get all heads or at least one tails? And does everyone see the addition rule right there? We can actually say that because you can't get all heads and at least one tails. So when we look at this mathematically right here, we can say that 1 minus all heads is equal to at least one tails. Put that in quotes here. So does everyone see that right there? 1 minus all heads, just doing the math right there. You can subtract right there. And so, and then Alex has all of them right there. Glad, I like seeing that. That's what I like to see in the chat. I've already feel like I've sowed in too much confusion tonight with a few little errors. I like seeing, oh, that makes sense. Because I'm either going to get all heads or at least one tails. And those are disjoint events that are complements. And complements add to 1. So we got a great rule right there that something plus its complement adds to 1. So you can just find the other side of it. I like that. Nice job, Alex and Tropical John, Elizabeth. Great questions. Let's take the next question and keep asking your questions. The researcher is collecting the average amount of potholes per mile. This one gets everyone every semester. I've only done it twice so far before this. But this is what they're interested. No, I just gave it away. Have you heard that? This is what they want to understand. This is what they care about, what they're collecting data on. It's what they're researching. It's the characteristic. I'm trying to use synonyms now instead of just saying it again. But it's what they're interested in. It's what they want to know. Thus, it is their parameter of interest, and we'll be seeing that here in half a second. But I guess it's a lot better this time because I kind of gave it away. The parameter of interest, also known as the population parameter, is what we are interested in collecting data on. It's what we want to understand for a population. Just think about this. Let's say UT wants to understand. Oh, great question, Ali. I'll mention that in a moment here. Well, I can say it now. The parameter of interest is what we want to understand about a population. So it can be the population parameter of interest or the parameter we want to know, but it's just the parameter of interest most of the time. Don't be confused if it's population parameter or population parameter of interest. Same thing. But the sample frame is the people or things we have access to. So the sample frame is the people or things we have access to. There'll be a question on that in a moment here, a little later. But the sample or frame is the people or things we have access to. Remember that. So the parameter of interest is what we want to understand about them, where the sample frame is what we have access to sample. I always use this example right here. If you went to Hodges Library and you asked students there, what's their favorite ice cream flavor? What's their favorite ice cream flavor? You guys can put that in the chat right here if you have a favorite ice cream flavor. I would say mine, I do like pistachio, and I haven't had that in a while. But the kitchen sink from Ben & Jerry's, or some sorbet, some nice like raspberry sorbet or something. That'd be great. But strawberry, everyone's liking strawberry. Strawberry sorbet. Oh man, okay, I've switched my mind now. Strawberry and lime sorbet together. Oh, that just sounds amazing. I do like mint chocolate chip too. And cookies and cream. How did I forget cookies and cream and cookie dough? So cookies and cream, cookie dough, all that good stuff. I like this, Cameron. So, okay. So what those people were answering right there is the parameter of interest. We want to know what flavors of ice cream UT students like. Now, you're all students in the UT library, and Tropical John and I got some cookie dough, because we're just giving you that ice cream once you say what you want. Do not words of wisdom from Matthew. Now, what would be the sample frame in my example? what is the sample frame in my example? So in my example right here, what was the sample frame? The parameter of interest was the proportion of favorite ice cream flavors. But what is the sample frame in my example? What would be the sample frame? Exactly, students in the library, or specifically with what we're doing, people in the chat. The people I have access to, students in the library, because theoretically I could talk to any of them. Does that make sense? I could talk to any of those students. Now, what would be my sample? What would be my sample? Hint, if you answered the question, you're my sample. So with that little thought experiment right here, if you answered their question, you are my sample. That's key right here. So people who answer are the sample, the things you get information from. The things you have access to, like the people in the library, are your sample frame. The question you're asking, kind of whatever you're asking about, like the proportion of ice cream flavors people like, that is the parameter of interest. What ice cream flavors people like, it's the question. It's what we want to research. And the population would be what? What would be the population? You can kind of go global or broad. It's a little ill-defined in this one, but what is the population? The population would be, you could say UT students or stuff like that. The population is everyone we want to understand, because imagine we're throwing a big campus-wide ice cream party. So we say we want to understand what UT students like as ice cream. So we went to the library to ask UT students, what ice cream flavors they like. And a census is when we get information from the full population, like the United States Census every 10 years. That's coming up real soon. And we get information from all people in the United States. That's the goal. A true census does information on every person, everything in the population that we are trying to understand. At that point, it's no longer a sample. You actually know the truth, and you have everything. Yes, Meredith, that would be bias. We'd probably have some, I'm trying to think of what kind of bias it would be. Probably some undercoverage, because not everyone goes to the library. That's exactly right. Nice job, Meredith. That would probably be undercoverage bias, and we'll do some biases here in a moment, but that would probably have a lot of undercoverage bias, because you're getting the students who, hopefully we can figure out some way they differ, but students who, maybe it's like a younger demographic who come to the library, so we're not figuring out what older people might like for ice cream, because if you're younger, you're more likely to be on campus. If you're more likely to be on campus, you're more likely to go to the library. Thus, we might see more people in the library who are younger, and we might not truly understand the population because we've underrepresented people who are older. Only smart people like ice cream. We want to supply to them. So there we go right there. I agree, Ren. We'll continue on right here. Joyful Hawk in the lead, and Elated Lizard jumped up. 8 answers in a row. Jeez. And with me messing you guys up, I like it. A researcher selects their sample based on the percentage of highway roads, country roads, and city roads. I see a few things in here. Be careful. They're selecting based on percentages. They're saying I need to acknowledge a difference between the highway roads, the country roads, and the city roads. They're acknowledging a difference, and then they're saying I'm sampling 30% highway roads, 30% country roads, and 40% city roads, because that's representative of the population. And they're going to pick randomly within these strata. I didn't say that word, but they're going to pick randomly within them, and let's see what you guys think. It is stratified. Now, I want to point out some key differences here. We'll see cluster in a moment, but with stratified, step number 1 in my book is to acknowledge a difference. We say, here's a difference in the population. Highway roads are probably different from country roads and city roads. I think everyone would agree, when you look at a road, you can look at a country road, a city road, a highway road, and they're different. Like country roads usually are more, gravelly, or might have more potholes because they're not always repairing them a bunch, where highway roads are usually kept in better condition, we hope, because they're highly traveled. So it's like these are the main roads people are using, and city roads might just vary. They might have more variation in them. They might be really good in some cities, really bad in others, but we'd hope everyone has good highways. We'd hope. Can't promise that. But with this in mind right here, in part 1 of the country rotation, I like that. In part 1, we acknowledge a difference in strata. And then part 2 is to sample within the strata by the percentages. So let's use, I'm going to put 40C, or let's go highway first. Like I said in the example, 30% highway, 30% country, and 40 city. So I want you guys to use these numbers right here, and these are the percentages we want to sample. If I were to take a sample of 200 roads, how many roads, and these are like segments of roads that I'm going to sample, like 1 mile segments, how many 1 mile segments would I sample from city? how many, in my sample of 200 road segments, how many of those would be city roads if I'm doing stratified? So with this in mind, 30, 30, 40, and Mitchell got it right there, 80 city roads. If you notice, I'm kind of organizing my sample by these percentages. So if I sample 200 roads and I want 40% to be city, I would sample 80 city roads. How many country roads would I sample? And I think Ali has the answer to that one. It'd be 60, and I'd sample 60 highway roads. And you kind of make this model what you're trying to investigate. You do it by the population. Imagine we wanted to look at, does UT need to build a new stadium? Like, we're just going to build a new Neyland Stadium. So with that in mind, let's say we were to talk to students and we were to stratify them in some way. What is some difference we might acknowledge? We're building a new stadium, maybe. What is some difference we might acknowledge? Or we'll just build on top. We'll build it even more. We'll put another 50 million in. So what is some difference in the population we might acknowledge between students to sample them? What is some difference with students that might have them different opinion here with their opinions on building on the stadium? What is some difference we might acknowledge? We could do it based on like class level. That's one way to stratify students. I was thinking like participation in athletics. Exactly right there. Or football fan. I like that a lot, Trevor. Whether or not they are a football fan, because that's going to kind of skew their view. It might be easier to stratify on if you're an athlete or not, but we might have students respond, are you a football fan? And then we make sure we don't overrepresent football fans because we not acknowledge that we need to get so many football fans and so many non-football fans, lest we have too many football fans or non-football fans and we don't get a good representation of UT. So we're all football fans, so it's a no-brainer there. So good stuff right there. Stratifying is when you acknowledge a difference. One of my favorite examples to use is how would we stratify donuts? How would we stratify donuts? Tell me a way to stratify donuts. How would you stratify donuts? And when you hear how do I stratify donuts, think how do I acknowledge a difference? Before you eat them, acknowledge that difference. Well, yeah, who made them? Krispy Kreme versus Dunkin' Donuts, shop brand versus like main brands, flavors of donuts, glaze versus sprinkles. All these things are acknowledging differences. You're doing it right there. You are stratifying them exactly. Imagine at Krispy Kreme, if they're trying to figure out if there's a problem with their donuts, you've got the glazed donuts coming off of the machine, and then you've got the handmade donuts. I think they make the other ones by hand. So you'd have two different processes. If they said, go out and sample the donuts, would you only go to the machine? Like if they said, how are the donuts today? Would you only go to that big machine they have? Would that give you a representative view of all donuts? And the answer is no. The big machine is a good view of the glazed donuts. So maybe if that's 60% of the donuts you sell, you'd maybe take, like 30 donuts from the machine, and then you take like 20 baked donuts and look at the quality. Because if you have 60% from the machine and you sample 50, you'd sample 30 from the machine. So what you want to do in Stratified is acknowledge a difference. There's a difference between the donuts made from the machine and the ones we're making by hand, and then you sample in accordance to that difference you've acknowledged. So, yes. What did John say? It's too many. John, you are very correct. I like it. So we'll continue on. Good job, everyone. So the probability of getting a multiple choice question correct is 80%. With 5 questions, what's the probability you get at least one wrong? This is a great one right here to practice in the chat and see if you get it. These are tricky ones. On a multiple choice test question, 80% chance of getting one right. You have 5 questions. What's the probability you get at least one wrong? And Elizabeth, I'm rooting for you on this one. It's because this will help see if you understand it. And we'll see if Tropical John, keeps up his streak. So let's think about what we have right here. Probability of getting a multiple choice question correct is 80%. So let's think about if you get the first correct and the second correct and the third correct and the fourth correct and the fifth correct, you've gotten them all correct. So you can either get them all correct or get at least one wrong. The answers are triangle, 0.672. Blue diamond, 0.732. Orange circle, 0.328, or yellow. And green square, 0.200. So with this right here, let's write it out. We want to figure out the probability of getting at least one wrong. And a big hint in the chat right now, it's 1 minus the probability, all correct. It is 1 minus the probability of all correct. So at least one, and at least, yes, the at least one is key right here. And it might or might not say that in the chat. Not in the chat, but in the on the test. I think a lot of times we do. Can't promise. It might say one or more, and which is at least one. But there's a lot of ways to say this. But if you can phrase something as at least one wrong, then that's key. And 1 minus the probability of all correct. And here we'll put the formula. And you guys are always free. I think you guys are competing so hard tonight. So I'll put this in the chat right here. It would be this right here. I'm solving the problem as we're doing it. So 1 minus the probability of all correct is at least one wrong. And sorry, thank you, Abby. I forgot to put the minus. I was typing it as we're doing it. Abby, you did it correctly. Nice job. I just missed my minus right there. And great job, everyone who solved it. Did you guys get this better the second time and see how to do it? Nice job, Thomas. I like the way you wrote it out. How different is it if I just put 1 minus probability? That's quite fine. And you don't have to write out 1 minus the probability of all correct when you do the test. I just think it helps because when you think about 0.8 to the 5th power, you should think in your head, nice job, Eric. You should think 0.8 to the 5th power is all correct. 1 minus all correct is everything but they're all correct, which means at least one wrong because you'll either get them all correct or at least one will be wrong. And that's the disjoint rule right there. So great job, everyone, on that. Keep it up. Any questions about this one? I think you guys are doing much better at these now. Did anyone kind of learn how this works and maybe be able to solve one of these now, which is kind of my goal. If we give you at least one problem on the test, you can just solve it right away. So I hope this is helping out and people are understanding how to do it a little bit better. We'll continue on right here. We'll see who is winning. It is Joyful Hawk. Okay, I'm going to go for Dazzled Fox. Foxes are all... Oh, wait! Clever Macaw is back! They're in 5th, but let's see. Oh, nice. You're good to go, Ali. I like that. For the sampling distribution of the sample proportion, what is the third condition? Okay, what is the third condition? Now, technically, they have no order here, but I like to teach it to you guys this way. Condition 1 is randomization. Condition 2 is 10%, as in less than 10%. Now, the third condition is where we need to pause. Pause on the third condition. You can put them in any order technically, but pause when you get to the third because it's different. And we need to ask ourselves, is this for a categorical question or quantitative? And proportion is categorical, so this is success, failure. Mitchell, you are correct, and everyone is just destroying that question. Nice job. Remember, sample proportion is categorical. We had one earlier where we were asking people if they were juniors or freshmen or different class levels, and that is a categorical question. Are you a junior? That's a categorical question. So when we ask a categorical question, the third question is success, failure. Success, failure states for Clevin right there, we want at least 10 successes and at least 10 failures. In the previous problem, we had that UT is equal to, or UT has 20%, UT has 20% juniors. I think those were the numbers. And thank you, Mitchell, right there wrote the formulas so we can see it also. UT is 20% juniors. We sample 80 students. So with this right here, check your NP, NQ condition. And this is for the sampling distribution of the sample proportion because it is P rather than P hat for confidence intervals. But let's see right here, check your conditions, do it in the chat and put it in there for people to see and to test yourself to see if you can see if this meets the success failure condition right here. Does P being 20 and N being 80 meet the success failure condition? And to meet it, both NP and NQ, when you solve them, need to be greater than 10. And this review will be online, Mario, so you can watch it and review it. And that's why I love it when people put the answers in the chat, because then people can see those answers and work them also. And Ali, there's the answers. And what you would write on the test is that right there. And then you'd simply say, they're both larger than 10. Now, I think I have a question over this, over the less than 10% condition. Don't confuse this with the less than 10% condition, because that says we need to sample less than 10% of the population. The success failure condition states are the NP and NQ, when you solve them mathematically, needs to be at least 10. You need at least 10 successes and need at least 10 failures. So that's what the success failure condition is. Does that help for people wondering what it is? We have Ruth and Zachary asking what is the large enough condition. The large enough N condition states that based on the shape of the distribution, if the parent population is normal, N only needs to be 1. So it's kind of moot This is for quantitative data, like if we're collecting how old are UT students, if the question is how old are you, then we would need a normal distribution to do the sampling distribution of the sample mean if it is only size 1. If the distribution is skewed, then the sample size needs to be at least 25, and if the distribution is heavily skewed, it needs to be at least 100. So what you need to ask yourself is this if you're doing the large enough n condition. 1, is the question quantitative? And then the third condition will be large enough n condition. So quantitative, large enough n. Categorical, success, failure. And then the key numbers to remember for large enough n are 1, 25, and 100. Because the more skewed it is, the larger the n needs to be. So remember it that way. The more skewed the distribution is, the larger n needs to be. If the distribution is normal, well then 1 works because it's normal and it doesn't need to be normalized by a larger n. If it's skewed, 25, and if it's heavily skewed, 100. And that's the way the large enough n works. And I like it, central limit theorem. They both technically use it. We usually show the example with the large enough n, but it's how the distributions become normal, and we can do that's why we can use, and I should say this, that's why we can use the normal curve. That's meeting these conditions literally means you can use the normal curve. There's a great practice problem on it where it asks what will the distribution look like, and it will look normal if you meet these conditions. That's the whole reason we're doing this, to use the normal distribution. So great questions there, great job. And we'll continue on right here. Let's see, Clever Macaw, come back up. Dazzled Fox right behind you. The law of averages is a fallacy. The truth is, so the truth is what? Now, the truth is called, the law of averages is the fallacy, and the truth is called the law of large numbers. It jumped out of my brain for a half second there. I had to close my eyes and think about it. The law of large numbers basically says that we will see the truth in the long run, because the law of averages is not a truth, it's a fallacy. Two independent events, let's see, past events do not influence independent trials. Nice job, everyone. I had to read through all my answers again, but that is not the truth. The truth is that if we do something now that is not contingent on the past, it won't influence it. I like to think about gambling, because you'll hear people say, like, I'm on a hot streak, I'm on a cold streak. Oh no, John, top up, get higher. But the law of averages, people would say, like, oh, I've lost a lot, I'm due for a win. That's the law of averages. That's a complete fallacy. The truth is that if you have a 10% chance of winning when you spin a wheel, if you've spun 20 times and lost each time, when you spin now, your probability is 10%. You're not more likely to win because you've lost a lot if the probability is 10%. Those are independent trials. So the law of averages is a fallacy. The truth is past events do not influence independent trials. Good stuff right there. So the big answer right here is past events do not influence independent trials. And the Daily Wire with Ben Shapiro. Oh my gosh, if that's Ben Shapiro, that'd be crazy. I highly doubt it, but that's crazy. We'll continue on right here. The list of roads that the researcher has access to sample. So let's see the list of roads that the researcher has access to sample. This is a great review question right now because we've already covered it. So let's think. These are the roads they can sample. The roads they have access to sample. Now, what would those be? Now, the roads that they get information from would be the sample. The roads they want to understand are the population. And they're also collecting on potholes, which was the parameter of interest, which means the sample frame is the roads they have access to. You guys are killing it on these definitions. Gosh, I want to see some high test scores. Thank you so much, everyone in the chat. You guys are just crushing these definitions. Sample frame is the people or things we have access to. Sample frame, sample are the things we actually sample. Don't be tricked by it. Remember, sample frame are the ones we have access to sample, the things we can get a hold of. Great job. Remember, ask those questions during the questions or between. Looks like we're pretty good on this one right here. We'll continue on. And Clever Macaw, Joyful Hawk might have to fall out of their nest. Oh, that's mean. But let's see. Joyful Goose is hopping up in the lead too. For the sampling distribution of the sample mean, what is the third question? Oh, you should know this one like that now. The sampling distribution of the sample mean, what is the third condition? You guys got this. Condition 1, random. I gotta make sure not to yell. Condition 2, 10%. Condition 3, pause and ask yourself, am I doing the sample mean or am I doing the sample proportion? And since we're doing the sample mean here, it'll be large enough n. And once again, what does that mean? What does large enough n mean? It means that the more skewed the distribution is, the larger n needs to be. For the sample mean, quantitative, which is quantitative questions like how tall are you, how much do you weigh, how old are you, those are all quantitative questions which will lead to a sample mean. The order doesn't matter, so I just like to do condition 1, condition 2, and then I always call it condition 3 because the first two are the same. So if you just boom, 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 you can't get those wrong. And then the third one, remember there's not really an order to them. The third one is different depending on if it's sample mean or sample proportion. Mean is quantitative, Zach, you are correct, and proportion is categorical. That is correct. Because if I ask you, do you like cookie dough ice cream, then I could figure out the proportion of people who like cookie dough ice cream. If I ask you, how tall are you, then I could figure out the mean of people's heights. I could take all the heights and get the mean of heights. Remember, it's a quantitative question. How tall are you is actual real numbers, and so that would be means. Quantitative is mean, and categorical leads to proportions. Great, great questions in the chat. So keep it up. Any question you have, feel free to ask. I hope I read those answers again. I think we did. So this is the terminology that we'll see on the exam. Pretty much. Can you explain the skewedness again? Exactly. I'm going to try to do it with my hand so we can see right here. If the distribution is normal, like if the question says it's normally distributed, how large does n need to be? So if it's normal, n only needs to be what? It only needs to be as large as 1. I mean, it needs to be large enough. It needs to be 1 or more. If it's skewed, and we usually use words for this, if it's skewed, n needs to be at least 25. If it's heavily skewed, then it needs to be at least 100. And so the more skewed the quantitative data is from the parent population, the larger n needs to be. And that's why we say large enough. So it's basically like, did you have a large enough n? And we could say something like, and let's see if everyone gets it here. The question reads, the distribution of UT students' heights is slightly skewed. We want to look at the sampling distribution of the sample mean, and we collect the information from 40 students. So does the condition work right here? The distribution of heights of UT students is slightly skewed. Or we could say skewed. Don't worry, either one works for this. It's skewed, and the distribution, and we collect 40 students. And then be able to explain why. We would say something like, since the distribution is skewed, n needs to be at least 25. Our sample size was 40. Thus, n is large enough. And just think about the things we said right there. First, we said the shape of the distribution. The distribution is skewed. And thus, we need a sample size, second thing to say, of at least 25. Our sample size is 40, and thus large enough. And that's how to conquer the large enough condition. First, mention the shape of your parent population. It is skewed. The parent population is skewed. Second, mention your condition. Since it is skewed, we need a sample size of 25. Third, mention the size of your sample. My sample size is 40. That is large enough. So where did 25 come from? Oh, that's a longer story, Carly. That is a great story for a lot of classes. We can actually show the central limit theorem theoretically. I can go into a lot of detail. I've got a lot of applets on this, and I'm more than happy to go into great detail on this. But 25, truthfully, there's no exact numbers. And I know that sounds crazy, like we're just making it up. But the way it works is we use these kind of guidelines in 201. But we can actually show mathematically that it works. And so what we're doing is a normal approximation to use z-scores. And these are great questions. Why 1, 25, and 100? It's just because these are kind of good standards for us to keep in our heads. And then if we go into upper level statistics, we can actually look at how normal it is, and we can actually try to fit some distributions to it, like a t distribution or a gamma distribution or a log distribution. Many distributions can be fit to see if they're a better fit, and that's where things get really complex. So great question. Why is it 100 at this point? And I can show you mathematically and theoretically, but just remember, at least for our test, 1 if it's normal, and that's very easy to show because the central limit theorem states that distributions will become more normal and tighter as n gets larger. And so skewed is kind of an ill-defined word. So what do we mean by it being skewed? It's kind of skewed. So we put that at 25 just for that word and 100 for heavily skewed. But once again, we can go into more detail in other classes, or I can always explain it on another time. Oh my, Jeffrey, yes, great question here too. All these great questions. And it's funny, I'll mention this. Caleb says for extremely skewed information, I'm not going to say what I want to say because it'll confuse things even more. 125 100. I had a conversation with Dr. Seaver about this, who's one of the people who mentored me, and I don't want to confuse anything by saying something that is a little too, it goes to all the mathematical theory. I don't want to say it. Why is it less than 10%? So the reason it's less than 10% is the way it works with finite populations and the way our math works. So there's a lot of good articles on this also, on why we actually have an error when we calculate it with the mathematics we're using. There's actually corrections for it. There's a lot of formulas people have come up with that work with this. But right now, remember, 10% condition is less than 10%. All these great questions right here. I like it. And a lot of these are great fodder, as Thomas says, for true-false. So Thomas is right. These could very easily be true-false questions. Let's continue on right here. Thank you for all the questions. I love talking some stats. Someone's up to 122 places. What? The researcher is unable to get information from certain roads. They cannot reach these roads. They were trying to get a response from them. They couldn't get a response from these roads. I'm giving a big hint right here. They could not get a response from these roads. They just could not. I think that pretty much gives it away. It's kind of the same thing if you call someone on the phone and you try to do a phone survey with them and they just hang up. Just think about what kind of bias that is. It's when you cannot get the response to the question. What kind of bias is that? And that is non-response bias. Non-response bias is when the people or things you are unable to get information from somehow differ from the stuff you are able to get information from. And so we had this road listed. We knew of its existence. We picked it in our random sample. And then when we drove out there, we just couldn't get to it. We weren't able to access it. And I want you to think, in this example, we're covering potholes. So if we can't access a road, do you think there's maybe something a little different about that road and it's going to cause bias? We're like, hey, every road we were able to get to was great. I think there might be something going on with these roads. Non-response versus undercoverage. Great question, Alex, right here. Undercoverage is when we actually fail to sample. So let's differentiate right here. Undercoverage would be if we went out and someone said, let's see how roads are around Knoxville. And I just drove around the city and I only got city roads. Well, I've undercovered highway roads. I've undercovered country roads. I've undercovered these roads if I don't include them in my sample. It kind of goes more towards what the researcher does if they do undercoverage, like they just did not go out and try to get these. But if they went out and tried to get a road and were not able to get it, then that would be non-response. And so that is the differentiation right there. Also with students, you can think of undercoverage as maybe I go around the library and I speak to students about ice cream flavors. We've been using that one tonight. And so you could say I undercovered students who don't go to the library, which would be maybe older students or students who commute more might not go to the library as much. So that would be undercoverage. Where non-response in this example would be if I went up to a student, I was like, hey, I'm doing a survey, I just need a moment. And they were like, I don't have time for your survey. And that's because they're not responding. I tried to get information from them and they did not respond. So that is non-response. So I hope it makes more sense. I hope right there, or sampling other things in a survey because you already have an audience. Convenience is just taking the first 3 rows because it's easy. Yes. Thank you, Alex, answering Alexa's question. Thank you very much. We'll continue on right here. Joyful Hawk and we Clever Macaw. No, I don't know why I'm rooting for you. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P hat? Ah, yes, you guys got this one nice and easy. 30 students are how many are freshmen? What is P hat? Now, the formula for P hat is X over N, and be putting in the chat. A lot of people use this to review. X over N, I'll type it too, and thank you for everyone typing it. I can type things too. X over N is equal to P hat, which is the number of successes over the number of trials. And this one here is pretty easy. I think you guys got it, because this is going to be, nice job, 0.15. That is P hat. So that is the sample proportion. P hat, which is just P with a little hat over it, is the sample proportion. Nice job. Ask those questions if you got them in between the question or whenever. Got that. Which of the following is not a rule of probability? I'm going to give a huge hint. Don't click right away. I'm going to go through these. So remember, the rules of probability, there's one on here we never talked about. The one we did not talk about can be thought about as the complement rule, but we don't call it this. So I'm just going to tell you the right answer right away. It's subtraction rule is the answer to this one. Subtraction rule is the answer. Subtraction rule is that answer. I don't want people to lose their score by getting tricked. Subtraction rule is the answer. A lot of people last time I think got tricked on this one when I did it. So the addition rule says that we can add together two disjoint events. And then we have all probabilities are contained between 0 and 1, and the set of all probabilities adds up to 1. A sample statistic is a estimate of the truth. So actually what you saw right there, that sample proportion was a sample statistic, Ali. So that is right there, p hat is a sample statistic, and p is the true proportion. So Alexa, p is the true proportion. That's like 20% of UT is freshmen. P hat is the sample proportion, which is 30 out of 80 students were freshmen in our sample. So when you have a p hat, it must be from a sample. So you must have a sample size, and then you must have how many successes there were, and then p is just the truth. So sample statistics come from a sample. You have to have a sample size, and population proportions are, or population parameters are the truth. So we have the population, or the population proportion. That's what I was looking for. Too many P's right there. Population proportion is 20% in a lot of my examples. Like 20% of UT is freshmen. That is the population proportion. And anything for a population is a parameter. So there we go right there. The proportion for the population that is freshmen. That's a lot of tongue twister words right there. Does that help you out, Alexa and Ali? Does that make more sense? A sample statistic is an estimate of the truth for a population collected from a sample. So you must have a sample size for a sample statistic. It's going to be calculated from that. Like a sample mean or a sample proportion or a sample standard deviation would all be calculated from some sort of sample with a sample size. Where the population mean is the truth for all UT students. Like we could say the incoming freshman class had a high school GPA of 3.7. That would be the population mean. But if you went out and talked to 50 students and they told you that their GPA was 3.65, then that would be the sample mean. So let's see. Let's continue on. Okay, let's do it right here. Question 21. The roads the researcher wants to understand. These are the roads they want to understand. So they're saying, let's understand roads in Knoxville. That's the roads they want to understand. Let's understand these roads in Knoxville. So let's understand these roads in Knoxville. What are we talking right here if they say, we really need to know what's going on with these roads in Knoxville? So let's call that our, what are we going to call that? We're going to call that our population. It is the population. Oh no! So remember, I know this has wants to understand in it. We might have lost some people's streaks right here. This is not what they want to understand about the roads. It's the roads they want to understand. It's like saying, let's understand the roads in Knoxville. Then the roads would be the population of interest. Does that make sense? I know I just said interest, but they do use these words a lot of times in different literature or disciplines. No, John, no. I'm so sorry. I do put a little bit of tricks in here. I'm not trying to catch everyone. But yes, the roads they want to understand. Because this never said anything about the roads. Because remember, the parameter of interest is the, oh no, Abby, we lost you too. There's a shakeup. The potholes is the parameter of interest, and the population is the roads they want to understand. Just the roads. They're taking roads, they're sampling roads, and all roads they want to understand is the population. Oh no, well, I'm sorry. This is not passing the class, I promise. And I promise these Kahoots I make a little quicker than we make the test. So no, what happened to our leaderboard here? Joyful Hawk, Clever Macaw. Joyful Hawk is, holy mackerel, Joyful Hawk. Who are you? Who are you? These are from chapter 10, I believe, correct. Yes, we've changed the chapters this year, so sometimes my brain gets a little fuzzy. This is the sampling chapter. The researcher takes too many city roads in their sample. Oh, we know this one. They take too many city roads. I know, he's really good. They take too many city roads, which probably means they didn't get enough of other roads. If they get too many of something, they probably got too few of another. So if you've already answered this question right now, think about what sampling method could they use to ensure that they get so many of these types of roads, so many of these types of roads, and so many of these types of roads. What sampling method could they use to ensure they get a certain amount of each set of roads? Nice job, Meredith, with the stratified. You are correct. And that's the way they can ensure they don't get too many of certain types of roads. They could do a stratified. They say, oh no, we want to make sure we get so many city roads, so many country roads, and so many highway roads. Continue on here. We'll see who's in the lead now. Joyful Hawk still crushing it. My gosh, they can't get a question wrong, can they? Nice job, Joyful Hawk. The roads that the researcher samples. So these are the actual roads in their sample. That pretty much gives it away. The roads that the researcher samples. So they actually get the information from these roads. I feel like we should have everyone buzz in for this one. This is probably one of the easiest ones. It's the ones that they actually get information on, the roads that the researcher samples. And please ask questions if you have it. I'm probably going to go quickly on this next one. I'd love to see everyone get it correct. Because if these are the roads that they sample, it is most definitely their sample. How do we do? Nice job. That is the roads the researcher samples. The sample frame would be the roads they have access to. Alex, trying to trick everyone there. So the sample frame are the roads they have access to, where the sample is the roads they actually sample. Let's continue. We didn't trick Joyful Hawk with that one. We did not trick Joyful Hawk. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is N? We got this, guys. It's guys and gals. This is another easy one. We got all these easy questions towards the end. We did all the hard stuff. I like to intersperse it. We kind of get, like, that's how the test can be. You have to change your knowledge around. N stands for sample size. We should be able to identify now that if we know UT is 20% freshman, once again, the answer to this one is 200. But if we know UT is 20% freshman, that is P. That is the proportion of UT that is freshman. 200 is the sample size, and 30 is X. And doing really, really great here. That's a pretty easy one right there. What is the sample size? So N is sample size. We'll continue on. We got to get some more difficult questions for Mighty Ant to crawl up that mountain and win. UT is 20% juniors. From 80 students, 30 are junior. Find the mean of the sampling distribution. Ooh, this is a wording one. Wait, it says mean. If you remember earlier, we said mu p hat equals p. This is a wording one because you see mean and you're like, wait, this is proportions. So mu p hat equals p. The answer is p. Hurry, the answer is p. Whatever p is, that's the answer. Hurry. Hurry. So let's see here. Nice job for those hurrying right there. And if you see in the chat, I wrote mu. I know that u is not quite a mu, but I don't have the extra characters on my computer right now. But mu p hat is equal to p. That is the mean for the distribution of the sample proportion. Because the mean for the distribution of the sample proportion is equal to p. What is the true proportion? And once again, we said this earlier. This is a great review right now. Earlier we said if UT is 20% freshman, and yes, nice job, Tropical John. If UT is 20% freshman, then what proportion would we expect to see if we sample? And if UT is 20% freshman, well then when I sample, I expect to see 20%. And that's what mu p hat stands for. What I expect to see when I go out and sample is the truth. And the truth is p. So that's the way to read mu p hat. The mean for the distribution of the sample proportion is equal to the true proportion, which is p. Make sure to identify these things. Once again, here's a big tip. Circle the numbers when you do a question and identify the notation. Circle numbers on your paper and identify the notation. It is key to many of these sampling distribution questions because then you can go to the equation sheet and make sure you have what is needed. There will be the equation sheet, so make sure you circle the numbers and identify what they are. That is one of my biggest tips. Definitely use it. So we'll continue on right here. How's Joyful Hawk still leading the way? A researcher decides to take 5-mile segments of roads and sample each 1 mile within. So they're taking 5-mile road segments and sampling every 1 mile road segment within. So think about this. They have taken a whole bunch and then they're doing a census. Now they need to take each 5-mile road segment randomly and then they're doing a census. So each 5-mile road segment is 5 1-mile segments. So that's a whole bunch of roads and then they're doing a census on it. And those are the key aspects of cluster sampling. So let's review right here. Remember, we're trying to distinguish between clustering and stratified. Oh, we didn't get as many on this one. We got it. A lot of people get confused on that one. So clustering is when we take a whole bunch and we do a census. What is a cluster of donuts? So we need to take a random what now? In clustering, if we were to cluster sample donuts, we'd choose a random what? We'd enumerate all the clusters and choose a random cluster, and a cluster would be a random what? Batches work, but I think donuts come better in what? A random what of donuts? What would be a cluster of donuts? What is a cluster of donuts that we could do a census on? A dozen. I like that right there, Allie. We could take a dozen donuts, and that would be a cluster of donuts. What is, if we go to the Coca-Cola factory, because we need some, Coca-Cola, let's take a cluster sample of Coca-Cola from their factory. Let's take a cluster sample of Coca-Cola. So what would be, we'd take a random what from the Coca-Cola factory. What would be a cluster sample from the Coca-Cola factory? And then we're going to do a census on this. A 12-pack, I like that. We got a 12-pack of soda and a dozen donuts. We got all this right here. Now remember, you are assuming that all these 12 packs and all these boxes are kind of just random boxes and random 12 packs. There's nothing like unique about them. How would you do a stratified sample at the Coca-Cola factory? How would you stratify at the Coca-Cola factory? How would you stratify? I have no idea, John. I like that. How would you stratify at the Coca-Cola factory? You could do that. Allie, I like that. I never thought of that. Time of day made. Like, yeah, that you could stratify on that. Bottles and cans. Trevor, nice there. Because do you see you're acknowledging a difference. Coke versus Diet Coke, Mitchell. Nice job. So every time you stratify, you need to acknowledge a difference. And you might say flavors, like that Chad too. So Allie said time of day, because you might say, well, the morning batches might be different from the evening batches, so we need to make sure our sample comes from the morning and the evening. Or the cans in the bottle might have different kind of problems, so we may need to make sure our sample of how our factory is doing acknowledges that different. Exactly, Raven, good answer too. That's all the good stuff right there. I hope people understand the difference between stratified and cluster. Stratified, simple random, cluster, census, and then systematic should be in there too. Systematic's another key word. Make sure to have these down. Also, has anyone been to the Quizlet I made for this? The Quizlet has a lot of these down. Has anyone looked at the Quizlet? If anyone wants to throw the Quizlet link in the chat, that'd be amazing if you have it up and going. But the Quizlet has a lot of this like review type notation and memorization stuff. And here we'll pause on this. What was a census again? A census is when you collect data on everything. So you do a census on a cluster as in you'd get information from the dozen donuts you have. So you would do a census as in get information from all of the dozen donuts. Now a census for the population is when you get information from everything in the population, like the US Census. Thank you, Alan, very much. So, and sorry, it's not showing it. Other people are showing it too. There we go. I think I can show these. Thank you everyone very much. It's blocking it. It's just Quizlet links. We should be good on that. Great job, everyone doing it. And Joyful Hawk leading the way. Which of the following is a rule of probability? Which of the following is a rule of probability? There's things we need to move out of our head now. And some of these are rules of regression, and there's only one rule of probability on here. So I'll answer that question in 1 second here. And then, so remember, the other ones are rules of regression. I think we are good. There's only one rule for probability on here. So the info you get from the dozen donuts you use to draw conclusions about the population. Pretty much, Chad, and you wouldn't do it just from that 1 dozen. You would take random clusters, like multiple clusters. So you would take maybe, if you worked at the factory, you'd maybe take 20 boxes of a dozen donuts. So it'd be easier to go to like the production line and say, give me a box. Like imagine you're a secret shopper for Krispy Kreme and you went in and bought a dozen donuts at, one store. You bought, well, you're going to buy, let's say 20 dozen donuts and you want to see what the quality is. And you have to watch out because if they're giving you 20 dozen, who knows if they're picking the best or the worst, and it's a random sample within each box. But assuming each box is a random box of donuts, or you could be the manager. Imagine you tell the people at Krispy Kreme to box up the donuts, and you just choose a random box or 5 boxes throughout the day, and you sample that box. Like you want to see how are the quality of our donuts. You could choose a random box and do a census on it and just eat, like 5 boxes of donuts a day. And you got to test them somehow, right? So the boxes themselves are the clusters, and you would randomly pick clusters. You don't just pick one cluster to represent the whole population. Clustering kind of makes it easier because it's easier to take the boxes of donuts and it's assumed that the donuts in the box are random, and then you randomly pick the boxes and you maybe pick 5 or 10 boxes to make sure your sample size is large enough to draw conclusions about your population. Does that make a little more sense, Chad, on how we might actually implement a cluster sample to help us sample? It's a lot easier than going and taking one donut individually. Yep, it kind of makes things easier, and people are like, wait, if the clusters are random, why can't I just take random clusters? And I always think to the donut examples. Like, if you can remember the donut example, you can usually figure out the examples on the test. Okay, Joyful Hawk leading the way. Probability of making one shot is 0.3. What's its complement? Uh-oh, we're not... Joyful Hawk's not going to get tricked on this one. The probability of making one shot is 0.3, so the probability of not making it is 0.7, just giving it away right there, because the complement is just 1 minus the event. So the complement, P and Q are complements. If P is 0.8, Q is 0.2. If P is 0.4, Q is 0.6. If P is 0.1, Q is 0.9. That's the way the complement works. We just add up to 1, and P and Q are... Yes! I love seeing that. I love seeing 100% right there. I think everyone knows, and a big thing to remember, P and Q are complements. A lot of people, it's a common question. I like it when people ask, how do I find Q? If P is 0.2, so it might... Yeah, is that what adds up to like a 90 degree or 180 or something? I think it is, right? I remember learning that. I haven't used that in so long. It's two angles that add up to something are the complement of each other, I think. 90, I knew it was 90. I haven't used that in forever, and wow, I remember that, Alan. 90 was the first number I said. I was like, I think it's 90. And then I said a few others, and I was wrong. Yeah, it's 100 for this one, so don't think about that. Standard randomized zero questions. Maybe we start with the easier ones so they explain... Yeah, I'll probably try to do that for the third one here, Alex. I think any suggestion you guys have that'll make this better for you guys... I like it to be fun, and I want you guys to understand it. And if you guys could, we got 3 dislikes. I don't know if it was the people trying to crash us or what. If you could just, slap that like button or just gently click it. It helps like the metrics on the channel. Maybe we pull in some people from other schools and stuff like that, and they can see what we're doing and kind of, helps out. I don't put any ads on this channel. I know you'll notice on my channel, unless YouTube starts changing the rules, I've never seen a single ad on the channel because I never hit that monetize button. I want you guys to be able to watch this all free. That's my goal. And look at those likes shoot up. Thank you guys so much. I really appreciate it. It's just probably going to help the metrics better. Smash that like button. Don't slap it. Smash that like. Thank you guys very much. I really appreciate it. So, and then we're just gonna get like, hey, they say dislikes are interactions, so I should be happy with that, right? So thank you to those people who came in trolling us hitting the dislike. Uh-oh, here's a tricky one. You asked for it, you got it. So remember, this is the one I was messing up. We need to figure out the probability of getting 2 heads from this simulation. Heads is 0 and 4. 0 through 4. Uh-oh, 0 through 4. So in this trial right here, I got heads, 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 tails, heads. In this one, I got tails, tails, heads, tails, heads. In this one, I got tails, heads, tails, heads, heads. In this one, I got tails, heads, tails, heads, heads. Then here I got heads, 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 heads. And this is what I would write below it on the test. And it says, what % of the time did I get 2 heads? When I look at this right here, the only time, and I think I'm looking at it, the only time with 2 heads is this one. That's 1 out of 5. So make sure it says, what % of the time in the simulation did I get 2 heads? 1 out of 5 times. And when you do 1 out of 5, you should get 20%. And I'm holding my chest right here, making sure that we got it right. And we did. So, exactly. You can go back over it. These questions should have been... Oh, yeah, I'm sorry. You only get a limited amount to type. We're very more specific on the test. We have a lot of great test reviewers who are very careful in being as exact as we can. A lot of us are very meticulous on it. And so, sorry, I only get like... Your Kahoot questions can only be like 40 characters long. So the simulation took up... I think this one was like the exact length. But I tried using pictures on one of the Kahoots and it didn't work so well. But yes... So good job. Sorry, I tricked a few people here, and I think we're on the last question here. Joyful Hawk destroying it. Is this the last question or second to last? 2 events that can be easily added together must be what? This is a great review. And look, we got the normal curve on there. Doesn't really relate to this. 2 events that can be easily added together must be what? I like that, John. And we converted a dislike to a like. Maybe I impressed them. They said, this guy's getting questions wrong. He doesn't know his stats. Oh, it's just... Oh, look. You can actually see up there. They've got sample size, sample mean, and standard deviation. Wow, that's cool. And they're actually doing, looks like some t-intervals right there. So that'll be for later on. So this one right here, and you notice there's 2 right answers. If we can add together 2 events easily, they are disjoint. Now, something key I wanted to point out. We got Joyful Hawk. Please take a screenshot of this, Joyful Hawk. Send it to me as long as we don't have 10 people emailing me saying, I'm Joyful Hawk. I'll be like, no. But let's see right here. I'm going to hop over to the face cam real quick. Okay. So here's the thing. There were 2 chapters we did not cover, but they are on the practice test. We did not cover confidence intervals. So I'm going to give you guys a confidence interval question right now. You guys ready to do a confidence interval question at the end? Oh, I owe you $10 now? Oh my God, Mitchell. How in the world? You are insane, Mitchell. I don't know how you do it. So here we go with a confidence interval question, and let's give it a shot. We go out and we want to understand what percent of UT likes cookie dough ice cream. So that would be the parameter of interest. We go out and we want to understand what percent of UT students like cookie dough ice cream. We talk to 100 students. And when I say we talk to 100 students, you should immediately write down what, because you can kind of summarize this problem for yourself. We want to understand what percentage of students like cookie dough ice cream. We talk to 100 students. Boom. There's your N right there. Nice job, John. N equals 100, exactly. Out of those 100 students, 30 of them tell us that they like ice cream. So 30 students told us they like ice cream. What would you write down when I say 30 students told us they like ice cream? So 30 students told us they like ice cream. Right there, a lot of people forget this one. That's actually X. Nice job, John, again. I wish I could jump you up in the leaderboard too right now. And then they're already solving p hat. Now be careful. Here's where we have to slow down just a tiny bit. X over n equals p hat. X over n equals p hat. And it can get confusing with the notation. So X equals 30. X is 30, which is how many students out of the 100 liked cookie dough ice cream. And then we can solve for p hat, which p hat is going to be 0.3. So p hat is 0.3. Does that make sense that p hat is going to be 0.3? So p hat is 0.3. And the difference between, so p actually, and good question, because p would not apply to this problem. P is the true proportion, which we don't know, hence we're making a confidence interval. X is the amount in your sample that responds affirmatively for these questions. So if I say 30 students say they liked cookie dough, then X is equal to 30. So X is the amount that respond affirmative to your question. And if we were doing a sampling distribution question, we would get P. Now watch out, this is a confidence interval question because we're going to make a confidence interval from this. So I'm going to use this right here, the P hat, to make a confidence interval. So P would not be given for this because we want to figure out what is the true proportion of students who like cookie dough ice cream. Make a 95% confidence interval and interpret it. You can pretend this is a test question right here. Start working it out. Now, the test question would tell you Z equals 1.96. So the Z-score for a 95% confidence interval is 1.96. So when we do confidence intervals, we won't know P, because that's the point. P is actually the true proportion of students who like cookie dough ice cream. But we don't know that, so we're going to make a confidence interval to estimate the true proportion of students who like cookie dough ice cream. So let's try to do that right now. I'm going to write it in the chat. Sorry, it's going to look a little worse than it normally looks. So I'm writing the formula in the chat for those who are stuck. And so check it out. Did someone already write it out for me? No, it's awesome. So here is the formula written halfway decent. The formula for this, and write it down on your sheet of paper. You'll be given it on the test, but it's p hat plus or minus z star times p hat times q hat over n square root. If you notice, there's 3 parts to it. The z-score is found by usually going to the David M. Lane applet or kind of knowing them in your head. But it's the area under the normal curve that is covered. It's the area under the normal curve. So when we cover 95% of the area, that's why it's like 68, 95. That's basically 2, and more exactly, it's 1.96. And John's recalculating here. But that looks about right, John. Looks about right. So if people can solve it in the chat, and try to solve it yourself, and when we get a confirmed answer, I'll be very happy. So try to solve it in the chat. Actually, I can solve it here too. Be very careful. It looks like, yes, it looks like it's 0.2101 to 0.389. So we're solving for the 95% confidence interval. And I'm gonna solve it right here. First, we need to find p hat, which is 0.30. times that by q hat, which is 0.70, and divide that by n, which is 100, p hat times q hat over n square root. And yes, it looks like they're right. That equals 0.04, and I'll copy this in the chat. That's the standard error, the p hat times q hat over n square root. And then we times that by 1.96, which is the z-score. And that gives us this. Now let's pause here. We only got a few more questions. But this 0.0898, what is that? Hint, it's everything after the plus or minus. So it's everything after the plus or minus, that's 0.0898. That is everything after the plus or minus. So what is that? 0.0898 is it's everything after the plus or minus, so it's the margin of error. Everything after the plus or minus in a confidence interval is the margin of error. Good thing to remember right there. The plus or minus, everything after it, is your margin of error. And then all you simply do is take 0.30 and go plus or minus that amount. If you notice, review back the formulas I've written in the chat, but this is the confidence interval here. Now here's a big thing. I hope people are watching to the end of this video. Who can interpret this interval? Remember, I was interested in, i.e. the parameter of interest, was the proportion of students who like cookie dough ice cream. So what does this interval mean? Interpret this interval in context of the problem. A lot of people have a hard time doing this, and I'm going to write some standard interpretation in the chat. I'm blank % confident that the blank is contained in the interval blank to blank. Oh, hit a slash at the end. I am blank % confident. I am 95% confident that the true proportion of students that like cookie dough ice cream is between the interval. Oh, be careful, Ali, your interval's too small. You did 1, you made a 68%. So good job, Ali, though, great job, because that is the correct interpretation. It's just make sure to times your standard error, which is the p hat times q hat over n square root by 1.96. Because when you go 1 standard error, that's 68. 2 is 95. 3 is 99.7. No, great job, Ali. You did the interpretation great. It's just make sure to do 68.95, use 1.96 times it. And that is a great answer right there. I am 95% confident that the true proportion of students that like cookie dough ice cream is contained in the interval 21.01% to 38.98%. And does that make sense to everybody right here? Look at my interpretation right there where we just plug and chug. I know it's kind of bad to plug and chug with like remembering stuff, but it really helps. I am 95% confident the true proportion of students that like cookie dough ice cream is between the interval 21.01 to 38.98. Perfect, Abby, right there. So yes. So it might not always be 95, but we'll give it to you. Like if we gave you a 90% on the test, it'd be 1.645. If we gave you an 80%, we would give you these numbers. I promise you that. These are the numbers for this. The z-score will reflect it. If it was 98, it'd be 2.3263. So there's a bunch of them, and 99 is 2.5758. This is so it's doing this a little too long. All those numbers in my head. And we would always give you these numbers. And as you can see, here's a good thing too. As we get more confident, the interval gets wider, but it gets less precise. And that's in the notes, if you remember. More confidence intervals are less precise. But what is one way that we can make our interval more precise by not increasing the confidence? Or we can make our interval more precise by maintaining the confidence. Because we could make it smaller. We could go to like a 20% interval and it'd be more precise. But what is one way we can make our interval more precise while maintaining the confidence level? And it goes back to the formula. Because p hat times q hat over n, well, it's over n, so we just need to make n larger. And if n is larger, it makes the interval tighter, make the sample bigger. Exactly. That's got it. That was a confidence interval question right there. Just going over a little bit of it. Make sure to know how to make a confidence interval. Lots of review with that. And trials, we usually do that in simulation. If you want to make a simulation better, increase the trials. And that's the law of large numbers right there for simulations. So going back to chapter 9, randomness, if you want to make your simulation better, you can increase the trials, and that'll give you a better estimate of the whatever you're trying to estimate with the simulation. So if you increase the trials in a simulation, your simulation gets more accurate, the law of large numbers. Any other last questions here? Whew, great review, everyone. I think we did an excellent job. Great stuff. I'm going to open up the live control room and while you guys are seeing if you have any questions. Thank you guys so much. If you do have tips, send them to me about how we can always make this better. You're welcome, Alan. Welcome very much. It's a lot of fun doing these, and I'm glad you guys enjoy them. When we're getting the dislikes at the start. Oh, man. You're welcome, Amber, very much. I hope this helps you guys. I was told by some people it really helped for the test, and I like that. That's always my goal. You're welcome, Tropical John. I'm glad it was a big help, Chad, Abby. You guys always have questions. You can email me at bs@utk.edu. That is my email. I don't know why people think it's interesting, but I am Brian Stevens. And thank you guys so much for participating. So, yes. The Joker took my hair on Halloween. So, yep, Joker took my hair. Oh, no. Feel better, Alan. Feel better. Let's feel better. Yes. If you are too sick to take the test, get us a doctor's note, and then you'll take the comprehensive final. The final's not really cumulative. It's more that we just ask some questions like, here's a question that could be on the final. You want to go out and collect data on how long students studied for the test and what grade they made. How could you display both of those variables? If you wanted to display both variables in one graphic, and you want to display how long students studied for the test and the grade they made, as in numeric grade. Hours they studied and numeric grade on the test, what would be the proper visual display? And we usually do these as a multiple choice. So this is usually a multiple choice right here. So, and your instructor should, and I'll say the answer, people say in the chat, we got less people now. The answer would be a scatter plot, and it would be a multiple choice question. And then if it said, what way would you analyze this data with what statistical tool? It'd be regression. So you notice there we asked something kind of, so histogram is univariate quantitative, and scatterplot is bivariate quantitative. And it's just kind of reviewing, like, a good way to review for those tools and technique questions are, what would I use and when? When would I use a mosaic plot? When would I use a t-test, which we'll get to later on? And so a scatter plot is bivariate quantitative, and scatter plots we do regression with. If you take the test Wednesday morning, if you don't know where exactly to take it and you're signed up for the morning makeup, ask your instructor. If I'm your instructor, email me, and you should be getting those emails if you need to take a morning makeup. And we know the rooms. We try not to disperse them everywhere. That way people don't get confused. And we just try to tell the people who are taking them for the morning makeups. And I'll probably be seeing you then because I'm proctoring some of the morning makeups, John. So I think I'm proctoring a lot of them. Yep, I think I am. Probably be proctoring the one you're at. So getting up early on Wednesday. Yeah. So, oh my gosh. I get to campus at like 8 a.m. on Wednesday, or I get there earlier because I'll be proctoring that one, I think, and then I'll leave at I'll leave when you guys leave, so it'll be a fun day. Okay, I think that's got it. So great job, everyone. I hope everyone's doing great, and remember to email me those questions if you got them, and thank you all so much for being here. I'm going to go ahead and end the stream.